Hello students, we are going to learn about rationalization of an irrational number. Rationalization of an irrational number. I'm trying to explain the things in a short way. Rationalization of irrational numbers. First of all, we need to understand what are rational numbers, what are irrational numbers, or quick revision. See, these types of numbers are all irrational numbers. Sorry, these are all rational numbers. Now the point is, which are irrational numbers? So numbers normally we see are all irrational numbers. Sorry, rational numbers. Then what are the irrational numbers? Let us see that. See these simple integers, decimals 8.25 is a terminating decimal, 1.7825 terminating decimal. These are rational numbers. This is a non-terminating decimal, 4.373737 and so on. This is a non-terminating repeating decimal, non-terminating recurring decimal. Such type of decimals, they also come in the category of rational numbers. Then what comes in the category of irrational numbers? Let us see. See, rational numbers, as we have seen the definition earlier, are the numbers which can be expressed in terms of p over q, where q is not equal to 0. Now, what are the irrational numbers? See, such numbers pi, square root 2, square root 5, cube root 4, fourth root 9, such numbers are said to be irrational numbers. Actually, the numbers which have the representation like this, like this is a decimal, you see 6.284654672 688590826 and so on. That means this is a non-terminating but non-repeating decimal, non-terminating, non-recurring decimal. Such type of decimals, they come in the category of irrational numbers, or any number which is expressed, or whose decimal expression is of this type, they are known to be the irrational numbers. Now, for example, let us see square root 2. Let us see square root 2. Let us find the square root of 2 as we were finding in the earlier class, 8th class. So let's see square root 2. What is looks like? Square root 2 looks like 1.4142135623730950 and so on. That means this is a non-terminating, non-recurring decimal. You got it? And that is the relevance, because it's a decimal representation comes out to be like this. Hence it is this is an irrational number, or in other words, it cannot be represented in terms of p over q, where p and q are the integers. Therefore this is an irrational number. Now let us see pi. Do you know what is pi? See, pi is the circumference of a circle divided by the diameter. Pi is the circumference of the circle divided by the diameter, right? So what do the scientists do in order to find the value of circumference in value of pi? They draw a very big circle and then find the circumference of that, then divide it with the diameter, and they do this practice through computers also, and they try to have more and more accurate value of pi. But the value of pi till today, this has to be seen like this: 3.1415926533896723846264333 So you will see that this is a non-terminating decimal and non-recurring, non-terminating, non-repeating decimal, non-terminating, non-terminating, non-recurring decimal. So hence this is said to be the irrational number, or you can say that every irrational number has this type of decimal representation. Okay, now let us learn how to convert the irrational, how to rationalize the irrational numbers. Let us start learning that. Before that, let us learn what is the result of the operations between the rational numbers and irrational numbers. Result of operations between rational numbers and irrational numbers. So for example, here, addition between two, a rational number, and square root 7, an irrational number. So students, this is altogether an irrational number. So let me say this way. So this is altogether an irrational number. Now multiplication of a rational number with a rational number, multiplication of a rational number with a rational number, 2 is a rational number, square root 7 is an irrational number. This multiplication is again an irrational number. Okay. Same is with the division. The division of a rational number with the irrational number, or the division of an irrational number with the rational number, that is again the irrational number. Right. Now, what about this case? Square root 144. In this case, we need to first find the factorization of 144, prime factorization, and that comes out to be like this. All right. And this way, 144 comes out to be 12. 144 comes out to be 12. And 12 is a rational number. So therefore, 144, square root 144 is a rational number. Right? So sometimes we need to have the calculation first before we decide that whether the given number is a rational number or irrational number. For example, this. For example, this here you see that there is one rational number, this one. This is one rational number, irrational number, and this is second irrational number. Now there is the addition. We cannot say this is an irrational number directly. We need to have calculation first. So we open up the bracket and root 7 goes with root 7, and the result comes to be 4, and 4 is a rational number. Therefore, this is altogether a rational number. Now let us take one more example. Here, 2 square root 7 divided by 3 square root 7. So as you see clearly, root 7 is divided with root 7. Root 7 is cut off with root 7, and the result is 2 by 3 only. And 2 by 3 is a rational number. Therefore, this is a rational number. So students, sometimes we need to have the calculation before we decide whether the given number is a rational number or irrational number. Now let us come to the main part. How to rationalize the irrational numbers. Let us start with this problem. So we want to rationalize this. All right. We want to rationalize square root 2. The problem can be in terms of what is the simplest rationalizing factor of square root 2. Or you can understand, see, we want to rationalize square root 2. So in that case, we have to multiply square root 2 with something. So the question can be, with what number we should multiply square root 2 so that it is a rational number. All right. So let us see how to find it. Now you know square root 2. Inside the square root, we should have two twos. We should have two twos. Two twos. There is only one 2 here. So we should have one more 2 under the square root. And that's possible only if we multiply this by square root 2. I repeat, see, square root 2, we want to rationalize it. And we want to remove square root. Simply, we want to remove square root. And if we want to remove square root, we should have two 2's. So one more 2 should be there. So for that, we should multiply with square root 2. So that it becomes like this. Square root 2 into 2, then pairing, then equal to 2. Or square root 2 square, then equal to 2. So therefore, simplest rationalizing factor of square root 2 is 2, which is square root 2. This square root 2 with which we multiplied. This is how we can solve it. Let us take one more example. What is the simplest rationalizing factor of cube root 243? Simplest rationalizing factor of cube root 243. Now, here again, we need to prime factorize first 243. So, cube root 243, we are prime factorizing. Here you find that the prime factorization of cube root 243 gives 3 raised to power 5. It gives 3 raised to power 5. There are 5 3's. So it gives 3 raised to power 5. In order to remove cube root, I repeat, in order to remove cube root, this 3, see here, this 3 should be stuck off with this power. All right, this 3 should be stuck off with this power. So this can be only if there are 6 3's. We are having 5 3's here, but we should have one more 3. Then only there will be 6 3's. So under the square, under the cube root, there should be 6 3's. You understood? If there is 6, if there is 6 here, in that case, if there is 6 here, in that case, we will be able to strike off 3 with 6, and in this way 1 over 3 will be wiped off, and in that case the number will become rational. But this can, how can we do this? This we can do by having one more 3 under the cube root. That means by multiplying cube root 243 by cube root 3. So we should multiply this number with cube root 3, so that, so we are multiplying cube root 243 with cube root 3. So what will happen? So this will be the result. This is 243. This is 3 only. Both are under the same cube root. So both are same surds, both are cube roots. Hence the bases will get multiplied. Hence there are 6 3's now. Hence we have 3 raised to power 6 now. Now the outer power and inner power, right? The outer power and inner power will strike off. 6 will get struck off with 3. All right? And the result will be 3 square and equal to 9. Therefore, simplest rationalizing factor is this, because we multiplied with this. Why is the simplest rationalizing factor cube root 3? Because we multiplied with cube root 3. So this is the simplest rationalizing factor. So hence we shall write on the final line now. So simplest rationalizing factor of cube root 243 is cube root 3. Students, this is how you have to write down the solution. So write down, first of all, you will write down this solution as it is in your fair notebook. Copy this from here. Then you solve the problems which have been assigned to you. All right. Now one more example I'm going to take. What is the simplest rationalizing factor? What is the simplest rationalizing factor of 5 cube root 392? 5 into cube root 392. So let us do it quickly. Okay. So the prime factorization of 392 gives this. There are 3 2's and 2 7's. There are 3 2's. So 2's are sufficient in number. See, 2's are sufficient in number. But 7 are only 2. We should have one more 7 here. We should have one more 7 here. Isn't it? If we are having one more 7, then it can be a triplet. And then this can be the 7 raised to power 3. And this way we can find the cube root. You understand that? Here, there is the power 2 raised to power 3, but there is power 2 raised to power, there is power, 7th power is 2 only. This we did. So we were dealing with this problem, cube root 392. So the factorization of 392 gives us 2 into 2 into 2 into 7 into 7. So we should have one more 7. As you see, this is cube root. So for 7 also, we should have power 3. For 2, we already having power 3. But for 7, we don't have power 3. We are having only 2 7's. So we should have 3 7's. 2 are already 3, but 7 are only 2. Why are we looking for 3 7's? Because we want, because there is cube root. So under the cube root, there should be 3 digits so that the power is 3. So therefore, we have to multiply with cube root 7 to have one more 7. Is it? What will be the result? Let us see. When we are multiplying with cube root 7, so when we are multiplying with cube root 7, what will happen? That you see here, what will happen inside there? So this is the prime factorization of 392, and what will happen now? Inside we are having 3 7's. There were 3 2's and 3 7's. So after tripling, so this becomes 2 into 7 after taking out the triplets or solving the cube root. So this is 2 into 7, and this gives you 14. And now this is a rational number. So in order to make this as a rational number, we had to multiply this with cube root 7. Hence cube root 7 is the simplest rationalizing factor. Still, the full number was 5 cube root 392. So when we multiplied with this cube root 7, we got it 5 into 14 because cube root 392 because this much, because the value of this much was 14, so 14 into 5 comes out to be 70, and this way we have converted this into a rational number. Hence the simplest rationalizing factor is cube root 7. Why? Because we multiplied with cube root 7. All right, now let us go for the next type. Here we are going to deal with the next type of the questions. These problems will mostly be of this type: rationalize the denominator of the given irrational number. Rationalize the denominator. So here the denominator in this number is square root 5. The number is 3 upon square root 5. So we have to rationalize the denominator. Denominator is square root 5. So we have to rationalize square root 5. That means we have to rationalize square root 5. How will you do that? First of all, we need to know what is the simplest rationalizing factor of square root 5. Now we have learned it well. So the simplest rationalizing factor of square root 5 is square root 5. So therefore, we are multiplying this with square root 5. We are multiplying this with square root 5. This means this one. We are multiplying this square root 5 with square root 5 so that the result will be 5, a rational number. But we have multiplied in the denominator. We have to do the same thing in the numerator also. Otherwise, this equality will get disturbed. This equality should not get disturbed. This equality should remain equality. Means both the things on both the sides should remain equal. दोनों तरफ चीजें बराबर रहनी चाहिए. वो बराबरी खराब हो जाएगी. अगर हमने नीचे स्क्वायर रूट 5 लिखा है तो ऊपर भी स्क्वायर रूट 5 लिखना पड़ेगा. All right, so we have multiplied the numerator also. What will be the result now? Result will be like this: 3 square root 5, and denominator is square root 5 into square root 5, which gives you 5. So this is the final result: 3 square root 5 over 5, and all finished. That's that much only for such problems. Let us take one more problem. Rationalize the denominator of 2 over 5 cube root 25. Now here again, we need to find the simplest rationalizing factor of 5 cube root 25. We need to find the simplest rationalizing factor of 5 cube root 25. So you calculate until I come to the next step. So 25 cube root 25. There are 2 5s. We should have 3 5s. There are 2 5s. We should have 3 5s. So only one more 5 is required. So that means the simplest rationalizing factor of cube root 25 or 5 cube root 25 is cube root 5. So we shall multiply the denominator with cube root 5. Simplest rationalizing factor of this thing, cube root 25, is cube root 5. So we shall multiply with cube root 5. We shall multiply this. We shall multiply this with cube root 5. This thing, denominator. So what will be the step? We are multiplying the denominator with cube root 5, and hence we are multiplying the numerator also. We have to take जो नीचे लेना पड़ेगा वही ऊपर लेना पड़ेगा, ताकि ऊपर और नीचे कट के 1 बनता हो, और 1 से मल्टीप्लाई करके आपको पता है कोई फर्क नहीं पड़ता. तो इस तरह से ये जो इक्वल टू साइन है इसमें डिस्टर्बेंस नहीं होती. So hence we have multiplied with the denominator with cube root 5. Hence we have multiplied the numerator also. Now what will be the result? Let us go for the result. Numerator comes out to be 2 into cube root 5. 2 into cube root 5. And denominator 5 as it is. This 5 is as it is. And cube root 25 means 2 5s, and this 5 one more 5. Hence we are having cube root 5 into 5 into 5, which gives you 5. which gives you this 5. Cube root 5 into 5 into 5 gives you 5. And that is the final step now. We are having 25. So finally, we have rationalized the denominator. Finally, we have rationalized the denominator. All right. And the final answer is 2 cube root 5 over 25. So this way only you need to do. Now we are taking a little higher type of this thing. Probably the last question. What will be the, or rationalize the denominator of 3 over square root 5 plus square root 3. So students, we have already learned what the simplest rationalization factor of square root 5 plus square root 3 is square root 5 minus square root 3. This you understand? Do you understand this? Do you remember this? These are the SRFs of each other. We simply change the sign in between. Here it is plus, then this is minus. We simply change the sign in between. अगर यहाँ पे माइनस होता तो यहाँ पे प्लस आ जाता, ताकि when we are multiplying them, a plus b into a minus b gives you a square minus b square. स्क्वायर से स्क्वायर रूट कट जाता है और नंबर्स रैशनल्स बन जाते हैं. So SRF, simplest rationalizing factor of square root 5 plus square root 3 is square root 5 minus square root 3. So what will be the solution? This way, so we shall multiply the denominator with square root 5 minus square root 3. Hence, we shall multiply the numerator also. Now, what will happen in the numerator? Numerator will have the simple multiplication 3 into square root 5 minus square root 3. But the denominator is a plus b. See students, a plus b into a minus b gives you a square minus b square. Mind the brackets here. Now square goes with square root. Here also and here also. The result, okay, which formula we have utilized? A plus b into a minus b is equal to a square minus b square. So what will be the result? 5 minus 3. Square root goes with square, 5. And here also 3. Okay, this gives you 3. Now, this is left with 2 only. So we are having 3 over 2. 3 over 2. And inside the bracket, this thing. Square root 5 minus square root 3. Now, let us take one more and final example of this. A little, complicated, so that you can solve all these problems of such type. Students, before you solve the problems which I'm going to assign you, you should note down these problems in your notebook by having the play and pause strategy. You can pause the video, you can take down the solution onto the notebook, then play. So you can have the play and pause strategy to note down these problems. Once you note down these problems in your notebook, exactly the way I have done here, okay, keeping all these equals in the same line, following all the formatting, then you try to solve the problems which I am going to assign you, right? So here, again, the next problem is rationalize the denominator of uh, 2 over 7 minus 3 root 5. So what will be the simplest rationalization factor of 7 minus 3 root 5? 7 plus 3 root 5. We simply change the sign. Here it was minus, now it is plus. So simply we will multiply with this. We have multiplied with this, the denominator and the numerator both. So what will be the result? Numerator simple, 2 into 7 plus 3 root 5, and the denominator a minus b into a plus b gives you a square minus b square, gives you a square minus b square. All right. So a square is 7 square is 49, And b square, so students, you see here 3 is not having square root, so 3 square will be 9. 3 का square 9 हो जाएगा. Okay, but square root 5 square gives you 5. So we have 45. So 49 minus 45. 49 minus 45 gives you 4. And 2 goes with 4. We are left with 1 by 2 only. So over 2 only. So final answer comes out to be, now there is no need of bracket here. See, there is no need of bracket here. So 7 minus 3 square root 5 over 2. So this going very simple way. So students, this finishes. All right. So now you need to solve the problems. Listen carefully. Will solve the last two exercises of the book now. Now all the things are covered and you can solve all those problems now. So you will solve all last exercises of the book. So solve now exercise 1.5 fully. Now everything is covered so that you can solve this exercise. And then solve the last exercise 1.6 also. This portion we have already practiced and covered in the previous lectures. All right. So complete your work and send to me by tomorrow morning 10 o'clock. Right. I'll assign you 3-4 more problems of the type last we have covered. And now there will be test on Monday. Thank you. Have a nice day.